So the second one is the integral of arc cosine of x dx. Integral of this using our integration by parts. So our u is that u and our dv is this. So uv. So u, which is arc cosine of x, our dv is dx. So our x is now x. If you integrate the x is x minus integral of v, which is x, du. If you differentiate arc cos of x is minus 1 over square root 1 minus x squared dx. I've done this video before, the derivative of inverse trig function, so go and just check it before coming back to this. So we continue. We can write this first. So s cos arc cos of x minus integral of x. You get x times minus 1 is minus x. Y, we can write this as 1 minus x squared raised to power minus half dx. So I have a reason for that, because from this I've said that integral of this form is this. If you notice that you are asked to integrate a product such that one is the derivative of the other one, so this is the derivative of the inner function, the answer is just add 1 over divide by the result. So we need to, because I noticed that if I differentiate minus x squared, I have minus 2x, but what I have here is minus x. So what I will do, I will introduce half, that's minus half, integral of, okay, maybe let me write this first, times minus 2x dx. Do you get 2 2? So we are left with minus x, so they're the same. So we now have that if you differentiate this, I have minus 2x, so the integral is now, the integral, our fx is this, so 1 minus x squared minus half plus 1 over minus half plus 1 plus k. So let's just simplify, which is now equal to simplify. This is half, so minus half times half is minus 1, so I have x arc cos of x minus 1 minus x squared raised to the power half plus k. So we can still write it as x arc cos of x minus square root of 1 minus x squared plus k. So that's our answer. So let's do the third one. So the third one is the integral of arc tan of x dx. So using our integration by parts, my u is this and my dv is that. So I have u, which is tan arc tan of x. Our dv is dx. So if you integrate dx is x, so our v is x minus v. I'm using integration by parts, so our v is x, and our du, if you differentiate this, we have 1 over 1 squared, that's 1 plus x squared dx. That's the derivative. So if you've not seen this before, go back to my previous video on that. This is x tan arc tan of x minus, okay, I want to clear something here. If you could remember, I stated that if you are given integral of fx raised to power n times f prime x dx, that the integral is equal to fx n plus 1 over n plus 1. Yes, it's correct, but remember that n must not be equal to minus 1. So if n is equal to minus 1, we can't use it like what we have here. Okay, let me just go to the next page and explain. I'll write this. You notice that what I have here is now integral of, if I have integral of x, 1 over 1 plus x squared, that we can write it as integral of x times 1 plus x squared raised to 1 minus 1 dx. So we cannot use this theorem because n. So we cannot use this. So it's wrong. Do you get? So, but looking at this, we'll see that we can write this as integral of x because this times over 1 plus x squared dx. And if I differentiate the denominator, I've done this before in my previous video, that if you differentiate the denominator and get the numerator, if I differentiate 1 plus x squared, I'll get 2x. So up will be 2x, and the answer is now ln of this denominator. So I'm saying that we can write this as, if I put 2x, 1 plus x squared, I'll counter it with half. Do you get 2? So we'll get back to this. So if I now differentiate this, the derivative of this is this. So our answer is now half ln. I've done it in my previous video. The ln of this, the natural log of this. So that's it. So I'm saying that this is now integral of half times 2x over minus half over 1 plus x squared dx, which is now equal to x arc tan of x minus half ln, because if I differentiate this, I have the ln of 1 plus x squared plus k. Though we can still write this as x arctan of x minus, logarithm raised to power half. So we now have ln square roots 1 plus x squared plus k. Do you get? From laws of logarithm, we now raise this to this, so which can be written as square roots. So that's the integral of arctan of x. Thank you.